All right, this is going on page 86 when we're done. You have known how to find the areas of triangles since like somewhere around 6th grade is when you start that, I'm not sure. And you've used that same formula over all these years. And I will tell you this. Now, I know you're not sitting in an AP class right now, but this pre-cal will be AP next year. It should have been all along because if you take pre-cal in college, you're pretty much doing this. But on the AP test, whether it's calculus, pre-cal, whatever, sometimes they give you some formulas for things, but then there are formulas that they expect that you know, like the area of a triangle. So that's not going to be on any kind of formula chart on an AP test. What is the formula that we know and love for the area of a triangle? 1/2 base times height, right? Base times height's a rectangle. You can think of the triangle being like half the rectangle. Little subscript of a triangle, so if you have a bunch of area formulas, it kind of denotes that. So that is your area formula. Boom, right? So that means that in order to figure that out, if we have a triangle, now if it's a right triangle, the base and the height are the two legs. But if it's not, then the base is the side of a triangle, but the height is some measurement that's not really a side or a piece of the triangle, and it's always perpendicular to the base. So if this is where I draw the height, that makes this the base. If I drew the height here, that would make this the base. The base of a figure is not always what it's sitting on. That's not the definition of the base, but when we draw it, we like to see them that way, just because it makes more sense for sure. So we're going to, just like we did with law of sines and cosines, come up with a formula that we can use to find the area of a triangle, not knowing the height, only using the A, B's, and C's, whether they're angles or sides. Okay? So this next part says we know that the sine of C. So here's angle C. If I'm going to find the sine for my right triangle trig, I'm going to use this little right triangle here. So that is opposite over hypotenuse. So that's equal to h over a. H stands for height here, not hypotenuse. And then when we solve for h, we're going to get a times the sine of C. Okay. Everybody with me so far? So then we can do some substitutes. So we're going to substitute this into the area formula for h. So here's my h in my area formula. Here's h here, which h instead of h is going to be a times the sine of C. And when I do that, so I'll get 1/2 times b times a times the sine of C. But when I write that, I'm going to flip the a and b around because the actual formula always has things alphabetical. So it's not exactly like I'm sticking it on the end. But it looks like this. Area of the triangle is equal to 1/2 a times b times the sine of angle C. Okay. So this is a times b times the sine of angle C. So notice the setup. That's two sides of the included angle. It's a side angle side situation. And even if we don't have any letters here, like there's no letters here, but this would be a times b. So this is C, so that's angle C. So a times b times the sine of C. Like you can label it with the letters if you needed to, but it's always the two sides and the angle that's included in there. Okay, we're good with that? Easy enough? All right, so let's look at number 1. It says find the area of the triangle. All right, so area of the triangle is equal to 1/2 times 2 of the side lengths, 16 times 11 times the sine of the angle included, which is 105 degrees. And then you can just type it in the calculator just like that. And you should get 85 point what? 001. Good. And then units. What would the units look like on this? Feet what? Squared. It's area. So when we substituted these in, okay, so this 1/2 came from the formula, bless you. This was 16 feet. This was 11 feet. This comes out to be a ratio that doesn't have units, so I have feet times feet. That's where you get your feet squared. Area is a two-dimensional measurement. Up until now, and for our purposes currently, area is always units squared. Saying that area is always units squared, period, not a true statement. You will get into calculus where we have some area stuff and it's not units squared. It will totally make sense why once we get there. I just don't want you to think, I hate the word always, like it's always units squared. It's always right now. When we're talking basic geometric figures, it is. Applications, sometimes things change. All right, are we all good? Okay. So this next one says the area of a triangle is 106 inches squared. So I have a triangle here. The area is 106 inches squared. Two of the side lengths are 25 inches and 21 inches. And the included angle is acute. Find the measure of the included angle. I want theta. Okay. So it's the area equals something, something, something. I have the area. So that is 106 equals 1/2 times the two side lengths, 25 times 21, times the sine of theta. I want to get theta by itself, so I've got to get sine of theta by itself first. This is all being multiplied by it. I don't care what the actual number is because I want you to do something specific in your calculator here. You have 106 divided by 1/2 times 25 times 21. And just hang on before you start pushing buttons. That's equal to the sine of theta. What do I do to get theta? Inverse. So it's fine to stop at this step and not write the inverse step. Totally fine, but make sure you actually do it. So you're going to do the sine inverse of this, but here's what I want you to do. I realize that you could do 0.5 as 1/2. And if you do it on everything else besides this problem, I'm totally fine with that. But I want you in this particular thing, just because I want you to do something on the calculator, hit your fraction button, put 106 in the numerator. Then when you go down to the denominator, hit the fraction button again, put 1/2 as a fraction, and then do times, because I want you to see that on these calculators you can also do a fraction and a fraction. Okay? I want you to have at least done that once. And like I said, moving forward, yeah, I understand sometimes 0.5 is easier, but if it was 1/3, could I use 0.3? No, you'd have to use 1/3. So, do those things smartly and you'll be fine. And then we should get that. Let's find the measure of the, so the measure of included angle is 23.817 degrees. It's fine to abbreviate. Just make sure that however you abbreviate, anybody else in this classroom, if they were to read it, they would know what you're trying to say. If you try to make up your own little acronyms or whatever, that's not going to work. But measure of included angle is 23.817 is plenty. What questions do you have? Anything? Okay. Let's look at number 3. So I want to find the area of the triangle. Do I have enough information to find the area of the triangle right now? No, because I have to have at least 2 sides, right? So I don't have enough information. Do I have enough information to find another side? Yes, okay. And I could find either side. It doesn't matter. We're going to find this side because I let second period pick, and I just like to be consistent throughout the day. That way I don't do something stupid either. All right, so we're going to find x. Again, we could have found the other one. Doesn't matter. In order to do that, would I use law of sines or law of cosines? Sines, okay? Because remember, for cosines, you have to have 2 sides because we're going to square them and add them together. So I'm going to use the law of sines. So the sine of 59 over x equals the sine of 76 over 7. So x is equal to 7 times the sine of 59 over the sine of 76. Okay, and because x is not my final answer, I'm not going to type that in the calculator. It's some number that I'll find, so I know that that's a number now, but I don't care what it is at this point. Okay. All right, so then now I want to find the area. So I have 2 sides, but I have to have 2 sides. Do I have the angle I need for area? No, because if it's these 2 sides, it has to be this angle. How do I find this angle? Add them and subtract from 180. And when you do, and use the calculator. You have the calculator in front of you for this. Use the calculator even when the numbers are easy so you don't do something ridiculous, because I've had that happen to a couple people already. I'm glad you're not calculator dependent, but. All right, so now that I have this, I can say that the area of the triangle is equal to 1/2 times the two sides, so 7 times x times the sine of 45. And just as a little side note, what is the sine of 45 with that? I don't want the calculator answer. The sine of 45. Square root of 2 over 2, because it's pi-4. You can push the button on the calculator, it'd be easier. But so now that I have this, look, this is x, this is x. So this is what I type in for x in my calculator. So 1/2 times 7 times all this in a fraction, then out of the fraction times the sine of 45, and boom, all in one step. And you should give you what you should get to make sure that when you're pushing the buttons, it comes out nicely. $15.304, are we good with that? What are our units on this? Millimeters squared. Good. All right. Any questions at all? Got it? Y'all good over there? Okie dokie. All right, so another one where they give us the area. So here's my triangle. Area of the triangle is 25 meters squared. Side lengths are 11 meters and 5 meters. And the included angle is obtuse. Find the measure of the included angle. So I'm looking for theta. Okay, so that means that the area, whoops, I don't need to write area. I do that almost every time I have the area. It is 25. That's equal to 1/2 times 11 times 5 times the sine of theta. So 25 divided by 1/2 times 11 times 5 equals the sine of theta. So go ahead and find theta. So she gets theta is 65.380. Is that my answer? That's what I got on my calculator too. But is it the answer? And why not? It says obtuse. It says the included angle is obtuse. Okay? So let's think about this. We're working with sine. We know that in the first quadrant, everything's positive. In what other quadrant is sine positive? The second quadrant, okay? Now, no matter what, when you get a positive angle measure out of the calculator, it's going to give you a first quadrant answer. If we did tangent inverse, and it's actually a third quadrant angle, it's going to give me the first quadrant. If I did cosine inverse, and it's supposed to be a fourth quadrant, it's always going to give you the acute angle, okay? So then we have to understand what to do with it, which is, again, not complicated, but I want to make sure that you understand what's happening here. So if, let's say, 65 is about like right here, okay? So that means that there's symmetry here, right? So it would kind of be over there. So this is 65. The reference angle is 65. So if I want, there's two angles that could possibly be an answer here. There's this one, which is what we got, and there's this one. How do I find the second quadrant one? Minus 180. Subtract that from 180, and that's your included angle. Yes, I think that sounded right, whatever you said. 114.620, yeah. So then we can say measure of included angle is, it was 114 point what? 620? Yeah. What questions do we have? Anything? Okay. All right, so let's look at number 5. I want to find the area of the triangle. I have to have 2 sides and an angle. I don't have an angle. Do I have enough information to find one? Yes. It makes absolutely no difference which one we find. We're going to find this one just because it's the easiest one to actually write theta in. Okay? That's the only reason behind my decision. Otherwise, it really does not matter. What formula do I use? Cosines. Okay, law of cosines. So theta is across from 16. So that'll give me 16 squared equals 6 squared plus 14 squared minus 2 times 6 times 14 times the cosine of theta. So that means I have 16 squared minus 6 squared minus 14 squared divided by negative 2 times 6 times 14. That is the cosine of theta. Okay? Now, because theta is not my final answer, I'm not going to push anything in the calculator just yet. Okay? We're just going to pause there. That's how we're going to get our angle. Okay? Then we're going to say, all right, now I'm going to go find the area. I only use 2 sides in the area. Which side am I not using? 16. Because if this is my angle, it has to be the 2 sides that include that angle, right? So the area of my triangle is equal to 1/2 times 6 times 14 times the sine of theta. Now, we're going to do this a little bit differently. Because I have been just saying, all right, we find theta, and we could just put it in here. And just like type all this in. But what this is really going to be is the cosine inverse of this, right? So you're going to have the sine of the cosine inverse of this, which is fine to put it all in one step. It just might kind of get a little nightmare-y. So instead, and we'll work on storing things later, but we're not going to do that right this second. Since I'm ready to type this stuff in, I'm going to go ahead and find theta. So go ahead and do cosine inverse of this mess. And you should get that theta equals 98.2 something. Now, when I find a number, a decimal, that I'm going to use again, I rarely actually write it out to 3 decimal places, because when you do that, especially those of you that aren't used to this or really understanding what I'm saying here, I would not type it back in. But I jot it down for myself to see, first of all, if it makes sense. Like if it was 287, it probably wouldn't make sense. Also, if I accidentally hit something on my calculator, I can see if I still was, had the right thing. So now that I have that, you have that looking at you in your calculator, then you can do 1/2 times 6 times 14 times the sine of the answer, and then it'll use that 98 whatever. And this is what you should get. Okay. Any questions at all? All right, so one reason I didn't worry about, hey, let's store it and let's do it this way, is because I'm about to give you a more efficient way to do it if we don't have any angles. So this works, meaning all we have to have is that one formula. It'll work for anything that we have, but there is something called Heron's formula, and it works when you have side, side, side. Okay? 3 sides, no angles. So yes, we can do it this way, but I'm going to give you a more efficient way. Okay? So it says when the measures of all 3 sides of a triangle are given, you can use Heron's formula to find the area. So one thing that we have to use is we're going to have this little s here. Okay? Well, actually, let me give you the formula first. Area of the triangle is equal to, it's a big old square root. And it's s times s minus a times s minus b times s minus c. So our side links are the little a, b, and c, which means s does not stand for side link. This is capital S's. These are lowercase s's, just because I know it's hard to tell when it's written. Okay? 2 completely different things, because again, side links are a, b, and c. So we have to know what s is. And even though this looks terrible, it's really not that bad when you look at what it is. S equals 1/2 times a plus b plus c. If I was just going to do a plus b plus c, what information about the triangle does that give me? the perimeter, okay? So this is half of the perimeter. What do you call half of a circle? A what? Semicircle, yes. So this is the semi-perimeter. Half a circle is a semicircle, half a perimeter is a semi-perimeter. What's another word for half? What's half of a sphere? Hemisphere, good. Took second period forever, and then when I said it, they're like, oh, like we've never heard these words before. Hemisphere also means half of it. Okay, so we got the semi-perimeter. So that's like a new concept. It's not super crazy, but, I mean, difficult, but it's half the perimeter. And that's pretty much it. So when we come here to do number 6, area of the triangle, that's equal to big old square root. Oh, wait. Oh, that's fine. We can do that. I don't know what the semi-perimeter is yet, so we need to find that. S equals 1/2 times 18 plus 19 plus 21. So, you know, I've been saying, all right, that's not my final answer, so we're going to wait. But I'm not using trig here. This should come out to at least a semi-decent number. Even if it's a decimal, it should be a decent decimal. So I can go ahead and find that. It'll make everything a lot easier. What would that give me? 29. And again, use the calculator. Even if you are capable of doing it in your head, use the calculator. All right, so that means then I have 29 times 29 minus 18 times 29 minus 19 times 29 minus 21. And even though the calculator is doing it, you have to show a setup. You can't just type that in. You have to at least write it down. You don't have to write down anything else. And even though the subtraction is easy, and this is a lot of button pushing, put it in exactly like it looks so you don't make some ridiculous, simple subtraction mistake. Not worth it. You should get 159.750 miles squared. Is that 0 that I wrote important? Yes, because if it wasn't, then I wouldn't write it, because I don't have to write more. But that tells me there's more out there that we rounded. So make sure you get that number. Do it all in one step. Makes everything easier. Any questions? We good? Okay. So then we have a triangular shaped piece of glass. All right, so here's my triangle. Side lengths that measure 35 inches, 27 inches, and 14 inches. Find the area of the glass and the nearest 10. Okay, so area. Okay, but what do I need to find my area? My semi-perimeter, right? So my semi-perimeter is 1/2 times 14 plus 27 plus 35. $38. All right, so you go ahead and fill in your square root, and then you can double check up here. If you agree with what I wrote down, then you can type it all in. So then is my answer 173.482, and why not? Anybody? Nearest 10. And so this is a story problem anyway, so we should be writing, so it says find the area of the glass. So I would say the area of the glass is, and I can finish reading that final sentence to make sure I have all my words in there. Oh, look, nearest 10th of a square inch. So that's 173.5 inches squared. So remember, near 3 decimal places unless you're told otherwise, or there's a couple other exceptions, like unless it's money, because if it's money, it doesn't make sense to 3 decimal places, like, use some logic there. But we good? Questions we got? Anything? All righty. So your assignment is in Delta Math. Go ahead and get that going.